Hi, we will start the session. Hi, very good morning, everyone. We welcome you all at Gyaniki Tech Talk session. Today is the 70th episode of Gyaniki Tech Talk session, and today we have joined by Shail Anant Pathak. He is a co-founder and director of Kairus Energy. Little bit I will brief about the Kairus Energy. Kairus Energy is specially means dealing in the battery product development, high performance battery side. The detail will be covered by Shell. Kairus Energy started in 2023 by the young professionals group of professional peoples are there with over combined experience of 20 years of experience from automotive domain. So please welcome Shell to our Gyaniki Tech Talk session. Hi, Shell.
Yeah, right. Firstly, thank you for the warm welcome, Arpan. And it is good to see that on a Saturday morning, so many, even 10 of us are coming together discussing about something that will be groundbreaking, definitely, because you know how battery technology is coming up in the future. And good to see so many people actively interested in such activities, and also happy to see Gyaniki doing something so wonderful for the industry veterans and also so many people that are currently active in this industry. Also, I would prefer more participation from all the people that are currently on the call. If you have any questions, if because this will be a discussion more than a lecture, let's not make it boring. I'll make it crisp. It is Saturday morning, so that we will finish this and then we all can move out. All right. So, can I
Yeah.
share my screen, Arpan?
Yeah, sure. Yeah.
Just a minute. Right. Is my screen visible? Is my screen visible?
Yes. Yes, sir. Yeah. Yes.
Right. All right. So I'll just give a brief introduction about our company, Kairus Energies. Kairus Energies develops battery systems for stationary energy storage, electric mobility, and high performance defense applications. These all our products are delivered with our patented thermal management system, which is based on liquid immersion. These particular aspects I'll be covering in the slides ahead, and how critical applications require high performance battery systems is what we will be looking at in the slides ahead. Most of you, if are well averse with the current market scenario for battery storage, will be knowing most of this, but the application side will be something that will definitely uh, spark some kind of thoughts in your mind as to where battery systems can be used or will be used in future. A bit of information about myself. I'm heading operations at Kairus Energies. I'm the co-founder and director as well. Previously, I did my bachelor's from Pune University in mechanical engineering, and then I did my master's in aerospace propulsions from Coventry University, UK. I have had more than 5 years of experience in the automotive industry, where I've worked on battery systems for electric three-wheelers. And now my work revolves around battery systems for special applications, ranging from energy storage, like harnessing renewable energy, automotive battery systems, and also defense battery systems. All right. So moving on. Firstly, what do you mean by high performance battery systems? High performance battery systems are systems that can primarily replace the actual energy source like diesel or petrol, and also completely shift on renewable energy resources like solar, wind, etc. They will not be just backup applications, but preferably on the front end, like how we have electric vehicles, and also the expansive growth that is going to be seen in the renewable energy industry. So as a company, when we started in 2023, we focused mainly on power in electric vehicles, starting from high performance four-wheelers. It was seen through the industry growth that currently the most amount of battery systems are going in BESS, in energy storage. And why is that? So there is a mandate that the government of India has put in, which is battery storage will be necessary in installation for solar and wind plant that are being put up. And with every solar and wind plant, a battery energy storage system has to be put up, which is mandatory. Even in COP26 that happened at Glasgow, our Prime Minister Narendra Modi announced that we have an ambitious target of 500 gigawatt worth of non-fossil fuel renewable energy resources that will be put up, which is solar, wind, etc. And to cater to that, 40 to 60 gigawatt of battery energy storage will also be put up by 2032. Currently, we are sitting at 232 gigawatt of renewable energy harnessing and zero point 0.4 gigawatt of battery energy storage system. So we are on a steady track to reach our targets. But still, energy storage industry in India is revolving around issues that are currently stopping us from progressing in that direction. We all know about the low safety aspect of electric vehicles that is coming into picture right now. Similarly, in energy storage industry also, there are containers that are being burned down due to a small thermal runaway action at the cell end. Similar, we are seeing in cars that are currently, the technology is getting better, but also there are some problems that are being seen in the industry regarding the safety. The low performance aspect, the considered life of a battery system is around 5 years for an energy storage system. The warranty is 5 years. Way before that, the battery systems are failing. Low energy density, you are seeing huge rooms and containers being used for installation of these energy storage systems. You required AC controlled rooms for installing these uh, power systems, and also these systems are not IP rated, so they have poor weatherproofing. So humidity becomes a factor. It reduces your range. Temperature variation also changes the battery system operation conditions, and all these result in high operating expenses and also results in lower safety and battery performance. So I'll be referring to the products that Kairus has built based on this comparison criteria. Energy storage systems are compared on five integral parameters: the power density, which is the power delivering capacity per kg; the energy density, which is the storage capacity, how compact you can make the battery system; life and cost effectiveness, which is very simple to understand, which is the amount of life and the cheaper the product is, as we are a cost sensitive market; and the IP rating of the battery products. Now in energy storage industry, most of the battery systems are IP rated of IP54 to 66, where they are dust proof, but high power water jets will uh, have a problem with the battery system. And high performance applications like automotive or defense applications or aviation applications, marine applications have battery systems that are IP67 rated to IP69 rated. So they are completely dust tight. They have no problem with water wading, so they can be completely immersed under water, and there won't be any problem with the battery systems. Considering all these factors, Kairus Energies has come up with the advanced battery modules, which is incorporated with our patented thermal management system. This patented thermal management system works in a certain way. The cells that are inside the battery modules are immersed in a special fluid, which is a dielectric fluid, which is thermally conductive and electrically insulating. So all the power electronics, the cells inside are immersed in this fluid, and this further is circulated and heat is dissipated through a casing. The casing has fins and cassettes that dissipate the heat outside. By this, we have managed to have rapid charging and discharging of 3C. 3C means 3 times the capacity of the battery. There is an inbuilt fire suppression technology, which I will cover in the next slides. The built-in extreme temperature resistant zones are such that we can operate this battery from -30 to +50 degrees Celsius. Now, for normal applications in our house inverters or in our EVs that are on road, you don't require this. But for certain defense applications or critical industrial applications that are remotely placed in sub-zero degrees, or applications that are in Delhi, you require temperature variation of as high as up to -30 to +50 degrees Celsius. The battery system, the IP67 rated, you can also perform remote diagnostics and usage statistics on the battery. By that, what I mean is they are incorporated with wireless and Bluetooth through battery management systems. And this is done through the BMS. So you can wirelessly access your battery system sitting far away. The battery systems have to be long life, low maintenance, and quick for installation. So diving a bit more in depth as to what the thermal management system does and what it is required to do in case of the cells or the safety of the cells. Lithium cells have to be maintained in a temperature zone, which is 25 to 40 degrees Celsius for optimum efficiency, for getting efficiency of up to 92 to 95%. And to get a life cycles of 5,000 cycles minimum. So you have to maintain it in the range from 25 to 40 degrees. If you cross that range, if you go below 25 degrees, you will find dendrite formation, lithium plating, which will reduce the life of the battery. And if you go above 40 degrees, you will see power fading. So you'll get less capacity over and over the cycles. So our thermal management system is based on our Hitch tech, which is patented. It is called hybrid integrated thermal management with cooling and heating. This patented thermal management system, it governs the temperature inside and identifies the heat spots. So what it does is, wherever in operation, when there is a heat spot, it circulates the fluid and dissipates the heat through the casing. The thermal management system, which is liquid based, also uniforms the temperature inside. So the entire cell stack is at the delta temperature of 1 degree Celsius. So the temperature is same across the entire cell stack. You can see a small image on the right hand side. This states the fire safety aspect. So we did a test at our end where two cells were subjected to external fire. One battery system was incorporated with the Hitch tech and one without. So the one without, when given external fire, it was completely destroyed in less than 3 minutes. But one with Kairus Hitch tech, it sustained for 50 minutes, and after 50 minutes, it vented out, but it did not have any explosion. And right now, that is one of the most important aspects, that electric powertrains or battery systems in automotive applications should not have any explosive reaction. Explosion takes place by three things. When these three things come together, an explosion takes place. You need a medium for fire propagation, you need the fuel, which is the cell, and oxygen. When this triangle gets completed, there is an explosion which cannot be avoided. So if you break this triangle in any kind of application, then you will be able to break the fire triangle and there won't be any thermal runaway. So far, am I audible? And if there are any questions, you can pop up directly. Hello?
Yes, you are audible, Shell. Participants, is there any question you have till now? Or if you want to clear that topics, you can ask. Jaideep sir, if you have, Jaideep sir,
Hello,
Ashwini
Shail.
Mishra.
Yeah, good
Hello.
morning.
Yes.
I
Good
have
morning.
one question here regarding the
cell temperature across the cell. You said 1 degree Celsius maintaining across the cells.
Right.
Can you help to understand how we are maintaining in terms of the cooling passes, how the passes is passing through the, let's say, for cylindrical cells or prismatic cell, and how able to maintain that temperature 1 degree?
Right. So, okay, I'll just skip this slide. I have mentioned it ahead, so I'll just go to that slide, explain it, and come back.
Sure,
So,
no problem.
yeah. So this whatever you're seeing on the screen right now, these tests we did at the facility, at our own facility. So the one on the bottom side, you can see that we have a comparison made where air-cooled batteries and high-performance Hitchtech batteries are compared. This test condition was done at 1.3 degrees C discharge rate at ambient temperature of 33 degrees Celsius. So it was experienced in the entire cycle that after the complete discharge, Kairus batteries were maintained at the deviation of 1 degree Celsius and air-cooled batteries had more than 5 degrees Celsius. So as I already mentioned that Kairus batteries have a liquid immersion based cooling system. So there is a liquid that is thermally conductive yet electrically insulating. So this thermally conductive liquid is circulated inside. There is a clever flow path that is maintained inside, and the heat spots are identified by the BMS. So once the temperature through the temperature sensors goes beyond the threshold, the circulation mechanism is actuated. At the casing side, on the where we are getting maximum surface area, there are cassettes placed where the transfer of heat dissipation takes place from internal to external. Did I clear your point, sir?
Yeah, understood. And how about the cost difference between the air-cooled battery and the thermally immersed battery?
Correct. So for that, I'll have to come to this slide. Now, when we talk about the Kairus Hitchtech batteries to conventional battery systems, Hitchtech batteries have the entire thermal management system inside the battery module. Whereas when you compare it with air ventilated modules, you have to have rooms where you are installing HVAC systems. And externally doing the fire suppression is very complex and expensive. So when you are immersing the dielectric fluid on the cell stack, it becomes very cost effective compared to conventional battery systems. This fluid is our own blend. It is our patented technology. This fluid has a flash point of 300 degree plus. So it won't itself act as a thermal agent. It will only reduct the heat. Also, in case of impact, for example, in automotive applications, in case of impact, this battery system also acts as an impact resistance between the cells and the casing. So yeah, all right. Have I answered your question, sir?
Question is, I mean, definitely it's going to help to have better thermal conduction across the cells and lower temperature. Again, the cost difference, let's say for 10 kilowatt hour capacity battery, what will be the cost for the air cool and what will be the cost for the immersed battery solutions?
Right. So for a air-cooled battery, generally it is 12,000 rupees per kilowatt hour. If we are looking at good cells, good compression assembly, and a robust BMS. And for a liquid immersion based cooling system, it will be 10% higher, which is around 13,000 or 13.5 thousand per kilowatt hour. So the difference is not much, but the performance increment is very high.
Understood. So if the cost is 10%, it's not kind of the, I mean, very good solution you are providing to the customers. It's not a huge kind of cost solution. So it's just a 10% on the air cooled battery, but benefit you are getting it, you can have charge, discharge, and you can have the safety issues can be avoided very well.
Right. And not only that, so this all aspects we've tested at an Enable accredited lab, which is TUV India. I'll be sharing those details also in the slides ahead. Right.
Okay, sure. So, thank you very much.
Yeah. So coming to this slide, I'll explain this again. This test was conducted at our facility where the battery systems, which were 48 volt 100 Ah, 4.8 kilowatt hour, were discharged at 1.3 C at an ambient temperature of 33 degrees. Air-cooled batteries were after the test, they reached very high temperatures. Kairus batteries were almost 70% cooler after single cycle, that is. And similarly, in the standard deviation, which Sir has mentioned, Kairus batteries were 79% less deviating temperature. So we were at a band of 1 degree over the entire cell stack. It is observed that in a cell stack, for example, there are 15 cells in series for a 48-volt battery system. The cells that are at far end will be cooler than the cell that is placed in the center of the cell stack. Hence, it is very important to homogenize the temperature. Also, if you can see the BMS board cutout here on the right hand side, it is shown that SOC is 2%. So after the entire cell is done, after the entire cycle is done, the voltage had spiked up again to 2 degrees, 2%. And the voltage difference between the cells is maintained at 27 millivolts. So what I'm trying to put forth here is that because of active balancing of the BMS, you can ensure 100% capacity. When we are discharging the battery system, one cell will definitely cut off the battery system at a higher end, and another cell will cut out the application at the lower end. Similarly, you can see the cell cutouts also. The temperatures were well within the range when the thermal management system was active. Right. So the most crucial tests for automotive in battery systems for
can you go back to, excuse me, Shail, please go to the previous slide, please.
Right.
One question I have here on the first graph, top graph. There is a difference in immersion cooled and the high-tech batteries.
Right.
I mean, they are using the same kind of technology, right? Then what is the difference of this 36% in the temperature?
Right. So here I'm have a image of the entire exploded view of a battery system. Okay. Now, immersion cooled batteries are using only liquid immersion as their cooling system or thermal management system. Here you can see on the right hand side and on the left hand side also of the image that there are cassettes that are placed. So there is and a pump is also placed for circulation inside. So this immersion fluid, when it's circulated, through natural and forced convection, the heat spots, the heat is dissipated to the casing, and from the casing there is a reaction that happens at the casing where the heat is dissipated outside. So we have a multi-phase cooling system on the casing.
Okay.
Right. That actually enhances the performance way further. So this is the step forward from liquid immersion as well. All right.
Okay.
Yeah.
Yeah.
All right. So yeah, the testing requirements for high performance battery systems, as we all know that in automotive it is AIS 156. For energy storage systems or for applications in defense, for applications in defense, like for marine application there is IRS testing, and for aviation application there is airworthiness certification. Both of this, they follow IC testing standards, and these IC testing standards are on the screen right now. For cell level testing, there is external short circuit, impact test, drop test, thermal abuse test, overcharge test, force discharge test. Most crucial testing of the battery systems in IC is the IC 62619. In this, the test of overcharge with voltage, which has to be cut off through the BMS. So these tests are all basically for the BMS, apart from one, which is the thermal propagation test. Overcharge with current test, overheating control test. So basically, if the temperature threshold has been passed, the BMS has to cut off the battery system. These all tests are run in a thermal chamber, and these are done at a NABL accredited lab. Then IC 62620 test, these are done for endurance level checks, and IC environmental module level testing. These are for vibration, dry heat, damp heat, corrosion, etc. So whatever environmental aspects are there in the environmental aspects are there on field, are tested at the testing side. So our battery systems have also been tested at a NABL accredited lab, and we have done complete IEC 62619 testing at our end in Bangalore. So these battery systems have been tested for thermal propagation test, which is the destructive testing that has to be conducted. And most of the customers are also happy if you're doing these tests. Apart from that, these battery systems are tested at minus 30 degrees Celsius. So an entire charging discharging cycle has been done at minus 30 degrees and plus 45 degrees. On the screen right now are the results for the thermal propagation test. The criteria for passing the thermal propagation test is that a particular cell will be internally short circuited. The particular cell voltage is 3.2 volts, so it will erupt to almost 50 volts in no time. When the cell erupts to 50 volts, the cell inside will go into a thermal runaway. This is mandatory for the test to pass. Once this cell goes into a thermal runaway, the criteria for passing is that there shouldn't be any explosion, the sprinklers in the thermal chamber should not be activated, and the temperatures should not cross the barrier. What happened during the test is, at 50 volts, the cell erupted and went into a venting action. But due to cutoff of oxygen, no cell in the neighboring side had any impact. So the cell that was meant to go into a thermal runaway bulged and went into a venting action. But there was no explosion, and this entire battery system remained as it is. And that is how we passed the fire propagation test. So that's about it for how what are the crucial tests that are conducted. The airworthiness tests and the IRS tests are currently in India done by government agents only, or in by government prone companies. Like in Lonavala, there is one firm that is conducting for marine applications. And for airworthiness, there is a company called Semilac that conducts these tests. So moving on to the supply chain challenges for high performance battery systems, we all know that almost 60% to 80% of the raw material of the total BOM is currently being imported, which is the cells. It is coming from cattle, Goshen, all prismatic and cylindrical cells are currently being sourced through China, Taiwan, and South Korea. Majorly around 80% through China. Observations were made such that the cell quality depends on the manufacturing batch and also on the make. For example, LFP cells that are made from cattle are different from LFP cells that are made by a company called EVE. Logistics that are conducted from China to India to your last mile delivery have a lot of issues. So customs is also something where there is a lot of material delay. Also, we are paying huge amount of import duty as the raw material is being coming from external entities. Supply chain issues are rising also due to these foreign entities and foreign affairs. For example, the previous war had a huge implication on the supply chain. Also, whenever there is a festival in China or neighboring countries, there is an issue as we have to plan accordingly to get all the stock in-house before the festivals. So we are very much dependent on external entities. Also, it is experienced that some homegrown companies are buying battery systems from Chinese companies, and they are reassembling and selling battery systems here. Now, the Chinese companies cannot directly sell batteries in India because they require Indian certification, which is BIS certificate. Hence, some companies are, reassembling the battery systems in India after purchasing it from China or neighboring countries. So now I would like to mention some real world battery systems that Kairus has approached and delivered. So this is one application where we have deployed Kairus electric gensets. So this battery system is completely charged through solar through a PCS. And this battery system also powers the entire residential and all heavy loads like AC, your refrigerator, your water pumps. So complete off-grid solution can be provided. Here, the cycle daily experiences almost 4 to 5 cycles of the battery system. So what essentially happens is, initially in the first half of the day, the complete solar is utilized for the load. Secondly, the load is shared between battery and the solar, and in the fag end of the day, the complete load is shifted on the grid. One such similar application is converting DGs into electric gensets. Again, here the advantage is that DGs are having OPEX cost of 550 rupees per hour, as the almost 6 liter of diesel is required to run a 20 kVA genset. Similarly, battery requirement is almost 7 per unit, 7 rupees per unit, which is 70 rupees for a full charge. So in OPEX cost, battery systems wins with a higher margin, and also they are very compact and very lightweight. Again, these can be charged through solar and grid. So the manual intervention of pouring diesel is not required. The battery systems are zero maintenance, whereas there is an annual maintenance for diesel gensets. These are some of the systems for regular applications like home backups, for server rooms, etc. at home and industrial as well. These provide around 1 to 4 hours of backup. They are having 5 years of warranty. You can use heavy loads also on these. Kairus battery systems, compared to lead acid batteries, are very compact. Lead acid batteries are almost so Kairus battery systems are 70% more compact than market average lead acid batteries. Also, they are very low maintenance and their efficiency is almost 92%. These are some of the installations we've done for residential and industrial applications. So the one on the left hand side, this is for ice cream factory in Pirangut. Then some of these systems are for lift backups, industrial lifts. A lot of requirements are currently coming from the warehouse industry, material handling equipment, like cleaning vehicles, then warehouse vehicles like forklifts, scissor lifts, etc. Also, marine port cranes is something that is coming up because these applications are in the remote places like ports. So you can't carry uh, the diesel tank that is inside the vehicle. It reduces the efficiency of the battery, and they are also trying to convert it in electrical. So these are some of the applications that we are currently working on. This is one of our project that we did at Tata Power, where we installed lithium batteries with our hitch tech. These are some of the applications for elevator backup and petrol pump applications. Kairus battery systems are being used for Tata's retrofitment also. So there is a current project going on where garbage vans are being retrofitted through battery systems. So we've done certain projects of that also. And the most amazing thing is that now lithium batteries or electric powertrains are being used in special advanced energy storage for defense applications. And battery systems are being used for weapons as well as for heavy UGVs, that are ground vehicles, and weaponized or even high performance defense applications. Potential applications in the aviation sector include radar systems, ground applications for material handling equipment, radar systems, and communication applications. So this is a image of the battery systems that we supplied for a marine application. This particular battery system is for a boat that is being run autonomous in Lakshadweep region. You can see the image on the upper hand side. This battery is a 144 volt 100 Ah battery system. that is powering the entire boat. This will be completely run on AI. So there is a intelligence system that is run on board. On the lower side, you can see these are stationary battery systems that are being used in remote applications. Here, the temperature will be minus 20 degrees Celsius. So these applications we've done with the Indian Defense as well. Thank you. So those are some of the products that I explained that we have done at Kairus Energies, and also the technology that we are utilizing here. So if there are any questions, I am open to that.
Yeah.
Thank you, sir, for taking us on the Kairus technology and kind of the product you have.
Right.
Few questions I have. Are you supplying to any EV manufacturers?
We are. We are mostly in EV. We are working with retrofitment companies, and also for defense applications, we are working with companies like Bharat Forge.
But any two-wheeler, three-wheeler applications?
We are not working two-wheeler, three-wheeler because it's a very cluttered market, and plus the cost effectiveness that is expected from them is too stringent.
Okay.
Right.
Because cost, you said only 10% difference against the air-cooled battery or water-cooled battery, right?
Correct. But then again, what happens is for two-wheelers and three-wheelers, there are so many players in the market, and the product that is being given, for example, there's a company who is using PCM cooling for their battery systems. Now, PCM, what happens is when there is a heat spot in a PCM cooled battery, at that particular instant, there is a latent heat of fusion. So the cell is dissipating heat, but that heat is being stored very close to the cell itself. It is not being dissipated outside. That is the problem with PCM. So when you're comparing immersion cooled with such cooling systems, it is very difficult to convince customers because they are getting the batteries at very less price, and they are not considering this as a critical application. So the battery systems are even further cheaper.
Okay.
Right.
So battery certified for all these EV applications as well, including from ARI or ICAT certified?
No. We have not certified battery systems for automotive application as of now, because once you certify one particular module for from ARAI, if a vehicle comes with a different packaging constraint, then you have to accordingly make a battery system for them and then again get it certified. So currently in automotive space, we are not working predominantly. We are working in e-mobility applications, which is material handling equipment or ground vehicles for defense applications.
Okay, thank you very much.
Right.
Thank you, Ashwini sir. Dr. R. Krishna Kumar, if you have any question, Jaideep sir, Hussein, Ju, anyone, Vaishnavi Vijay?
Sir, I have one question.
Right.
Sir, means you are testing the battery according to the applications, like you have told there are marine application, defense application.
Right. Yes.
Other. So does these application need any specific standards for testing?
Right. So I mentioned in my previous slides the IEC testing standards. These are predominantly required for marine applications. Further tests there are some customization when it comes to marine applications, like you have to completely immerse the battery system in under the water, and certain applications are with the vehicle. For example, if there is a 15-meter boat, so the battery system will be tested with that boat in case of IRS testing, which is the standard for marine applications. Does that answer your question? Hello.
Rohit, I hope you got your answer.
Yes.
Also, one more thing is, if you check IRS, which is the governing body for testing for marine applications, you will also get other testing requirements that are not pertaining to battery, but systems that are accessorizing with batteries. For example, chargers or onboard motor controller and motor, how they are behaving with the battery. This is also mentioned in the IRS testing for marine applications. For aviation, it is airworthiness testing. This is done by Semilac in India.
Okay, so and
Hi,
I want to
Sai.
Yeah, Vaishnavi, go ahead.
Yeah, thank you, thank you. So, hi, Shal. I actually joined a bit late. My question was like regarding the tests you mentioned. I observed few. So, in the what is the how you are doing short circuit test, and what would in your maximum? What is the maximum short circuit current like you have tested at different extreme conditions? That is one thing. And I also want to know that while the battery is in a prolonged time of use, due to temperature we get some issues, right? Field issues or like any issues it could be. So what issues have you observed, anything you observed in your deployment things, and how you have solved such things? Any
Right.
ideas would be appreciated.
Correct, correct. So actually, this is a very, very, very good question, ma'am. Why? Because I have experienced this in the industry when our battery systems are at customer end. So the first question I think you asked was regarding the short circuit event. Regarding the short circuit event, in the test labs, it is generally done inside a thermal chamber, and then a single cell is made to go into a thermal runaway by short circuiting it. This test is a destructive test. This is done so that one single cell will explode and it should not carry out the thermal reaction to the neighboring cells. So it should vent out. Now this is one destructive test. Other short circuit test is where instantaneous spike load is attached to the battery system inside the thermal chamber. Here, the battery management system has to cut off before the short circuit event takes place. So here the BMS is very important in this case. So this is tested at TUV India, which is an enable accredited lab. The second question that you asked was what are the field issues which were expected? Generally, what happens is in testing conditions, you are testing the batteries according to you. So you don't see a lot of field issues happening at your end. In field, it is experienced that sometimes the inverter or the motor controller, it can behave abnormally. So it is experienced that suddenly the load, which is generally 100 ampere, can range up to 200 amperes for a spike. For example, if immediate brakes are applied on a high torque application, in that case, the BMS becomes a very important point and it needs to cut off the application before it reaches the battery. Second is regarding temperature. The temperature control zone has to be between 25 to 40 degrees Celsius. If the temperature is beyond 40 degrees, the battery system will start operating at a lower efficiency. And it is experienced that, for example, our one application is in Ratnagiri, where the temperatures get beyond 45 degrees. And when in operation, then the cells without cooling, it goes up to 50-55 degrees Celsius. If the cell temperature goes beyond its optimum range, essentially we cut off the we tell the BMS to cut it off. So that is how we are safeguarding our battery system from external problems. I hope that answers the question, ma'am.
Yeah, Shal. Thank you very much for the detailed answers. Thank you.
Yeah. With us, Mr. Prajwal Khudare. He is leading startup company P5 Hybrid Energy Solution. Prajwal, sir, if you have the question that you have internally discussed, you can ask with Shail Pathak. Prajwal, please unmute yourself.
Hello.
Hi Prajwal.
हेलो सर। सर मेरी स्टार्टअप कंपनी है फीफा या हाइब्रिड एनर्जी सॉल्यूशन। हम रूफटॉप सोलर प्लांट करते हैं रेसिडेंशियल और कमर्शियल के लिए। तो
अच्छा।
आप वो बैटरी का कुछ बता रहे थे, बैटरी परफॉर्मेंस का कुछ। तो कैसे क्या यूज कर सकेंगे हम सोलर इन्वर्टर के साथ में, उसको कैसे क्या सॉर्ट करें?
राइट। सो अभी आपका सोलर इंस्टॉलेशन कितने मेगावाट का रहता है?
मेगावाट में नहीं रहता सर, हमारा किलोवाट में ही रहता।
हाँ,
यानी
मतलब आपका एनर्जी
तीन
स्टोरेज
से लेके
जो,
15 किलोवाट तक के किया है मैंने अभी तक के।
हाँ, तो मतलब आप एक्सपोर्ट कर रहे हो?
नहीं नहीं, एक्सपोर्ट नहीं है। एक्चुअली
हाँ,
हम खुद बैठाते हैं उसको, इंस्टॉलेशन है हमारा।
करेक्ट करेक्ट, आप इंस्टॉल करते हो, बट इंस्टॉल यू आप एक्सपोर्ट करते हो ना उसको, मतलब द
हाँ
एनर्जी
हाँ,
दैट यू। हाँ,
बराबर बराबर एक्सपोर्ट करते
करेक्ट,
हैं।
आप ग्रिड को डायरेक्ट फीड कर रहे हो, राइट?
राइट राइट।
करेक्ट, सो हियर यू आर ट्राइंग टू गेट द सब्सिडी और आप इलेक्ट्रिसिटी बिल आपका नील कर रहे हो।
राइट राइट
करेक्ट। अभी ये आपका ऑन ग्रिड सिस्टम हो गया। नाउ
राइट सर।
विद दिस कम्स एन ऑफ ग्रिड सिस्टम, फॉर एग्जांपल
ऑब्वियस
आपका जो इन्वर्टर और बैकअप आया, राइट,
राइट
वेर वी यूटिलाइज बैटरी सिस्टम, वेन एवर देर ग्रिड कट आउट होता है तभी हम बैटरी सिस्टम यूज करते हैं। If we use a hybrid inverter, sorry, off-grid inverter, hybrid inverter will export the system to grid. But if you use a off-grid inverter, you can have DC panels that can directly charge your batteries through the inverter, and that battery can be used to utilize the load in your residential applications.
राइट सर।
In that
मैक्सिमम
case,
कमर्शियल
हाँ,
साइड में ऐसा करते
कमर्शियल भी, कमर्शियल साइड पे भी ऐसा कर सकते हैं। जैसे आप अगर कंप्यूटर लैब देखो एग्जैक्ट, तो आपको पता होगा कि मॉर्निंग के टाइम सबसे ज्यादा सोलर का यूटिलाइजेशन होता है, राइट?
हैं। हाँ हाँ सर।
हाँ, सो एट 7 o'clock सोलर स्लाइटली इंक्रीज होता है, तब भी बैटरी विल बी ऑलरेडी चार्ज्ड। तो बैटरी और सोलर में डिपेंडेंसी होता है। फिर अराउंड 12 o'clock बैटरी से डिपेंडेंसी चला जाएगा और आपका सिर्फ सोलर का कंजम्पशन होगा। आफ्टर दैट एट 3 o'clock आपका सोलर स्लोली रिड्यूस होगा और ग्रिड पे कंप्लीट डिपेंडेबिलिटी जाएगा। करेक्ट।
राइट सर।
In that, if you are storing energy in your battery through solar, then further you can utilize solar and harness the solar energy.
राइट सर। नहीं, आप सोलर बैटरी के लिए बता रहे थे, तो उसमें क्या एडवांस है कुछ ऐसा?
The thing is, अभी जो lead acid batteries है, those cannot be charged at higher discharging rates or higher charging rates through the solar. So for example, at peak solar you won't be able to charge lead acid batteries the same way you can charge a lithium ion battery. Similarly, with compact space, you can utilize more lithium ion batteries to store this energy. जैसे
राइट
कमर्शियल एप्लीकेशन में आप 2 घंटे का बैकअप दे सकते हो, यू कैन ऑल्सो हैव वन एंटायर डे ऑफ सोलर जनरेटेड एनर्जी एज बैकअप। तो आपका जब भी थर्सडे आएगा, मेंटेनेंस डे आएगा, तभी आप आपका पूरा स्टोर्ड एनर्जी यूज कर सकते हो। And
राइट
one
सर।
more important factor is that currently many industries are also doing is peak shaving. आपका जो जोन डी है, जहां पे आपका सैंक्शन लोड से ज्यादा जाता है लोड, उस टाइम आप ग्रिड से ना लेने बजाय आप बैटरी से ले लो एनर्जी। तो आपका जो पीक जोन है, तब भी आपका इलेक्ट्रिसिटी जो यूनिट्स कंजम्पशन है वो कम आएगा।
राइट सर।
पीक शेविंग करंटली इज बीइंग यूटिलाइज्ड एज अ, मतलब जहां पे भी इंटेलिजेंट बैटरी सिस्टम्स लगाए हैं, वहां पे पीक शेविंग बहुत यूज होता है, राइट?
Okay. Is there any more question from the audience? Arvind, Arun Malani, sir. Hussein, Ju.
Sir, you are doing any project in southern part of India like this?
We are
You
doing a
have any
project in
plans?
Chennai.
Chennai, any specific industry, sir?
I won't name the industry, but this is going to go on the port.
Okay. Nice,
Right.
nice.
So this is for a big crane application. It's a huge battery storage system which is almost 500 volt and 100 Ah. So 500 kilowatt hour battery system for a crane application.
I think you are using in this Ennur port, right? Chennai Ennur port is that place.
Right.
Okay. Fine,
Yeah.
sir. Thanks.
We've also delivered battery systems to Kochi Airport. So these trolley vehicles, electric powered trolley vehicles, we are providing battery systems for that.
Yeah. Because in Kerala, many places are converting into
Right.
EVI. Because I'm from Coimbatore. It's just 200 kilometer for me, Kochi.
Okay.
I can see many changes in EV, especially starting from two-wheeler to four-wheeler. They are converting into electric, and also government also supporting for EVs in Kerala. Lot of EVs.
In fact, more than the automotive sector, these side requirements are coming a lot. For example, as I mentioned, material handling equipment or even energy storage as an industry for renewable energy harnessing.
Yes. And also this Kochi airport is full of solarized, I think so.
Yes,
Full of
yes.
solarized.
And that is one of the most old solar installations in India.
Yes.
Okay, yeah. So, is there any question, or shall we conclude the session here? Participants, if last minute, if you have any question, please take it up quickly. Okay, fine. So there is no more question from the audience. Yeah, it's a very wonderful session, Shell. Very interactive as well as a very knowledgeful session. You give the details about this battery technology very in depth. Then what are the testing and certifications thing, and about your Kairus innovative product also. So it's very good session that you have delivered so nicely and very simple. I hope all the audience got know about this battery technology, but especially high performance battery technology, not for the automobile side, but also for the renewable or side, as Shell already speak on that. So there are other verticals also where this battery storage system are used in the industry side, in other infrastructure also. So thank Shal for delivering this session, 70th. It's very good session that we have done today. And thanks to all participants who joined us today and make this session successful. Those who want to connect with Shail Pathak, you can directly visit the website www.kairusenergies.com, and you can drop contact or info there, so they will reach out to you if
Right.
any
In fact,
requirement or any connects you have.
Even if someone is interested, you can directly have my number from Arpan.
Yeah, sure.
All right. Yes.
Yeah, thanks, Shell. Yeah.
Thank you, Arpan. Thank you so much.
Yes.